Yeah, in today's lecture we will see the continuation to the previous lecture, and I am showing the question now. Exactly what we are doing is we are dealing with a problem in mechanics, and within this mechanics we are discussing some problems that are based on plotting. So here I am showing a question which typically may be from AIIMS exam. So here this is the actual question paper, and sometime in 2003 you have a question like this. An object is moving from rest and it moves in straight line with a constant acceleration. If you plot a graph between speed and the distance, how the graph will look like? So that's the question. Of course, in the actual question paper you have the 4 options A, B, C, D, and under each one of these options you have the graphs. So some graphs are given here, and your job is to choose the correct graph here. So some graphs will be there here, and we will see. And right now we are not going to straight away jump into the 4 options and then choose one of them. So that's not the way to do the problems in physics. We have to first solve the problem and then look at the 4 options and then choose the correct answer. So that we will do now. Now, before going into the solution methodology, let us understand the problem. Something is given here in the problem. The first thing is the object is moving from rest. So things are there here. So let me put it down. So an object is moving from rest, which means that the initial velocity is 0. That is the first point. Second point is the object is moving with constant acceleration. Therefore, we say that acceleration A is a constant. And there is a third point, that the object is moving in a straight line. So therefore direction is fixed. So that means you are not going to change the direction of the particle when the particle is moving. So direction is fixed. It is going to be moving in a particular direction. So what is the meaning of that, and why do you want to know all these things? Is because when the direction is fixed, what do you mean? The meaning is that velocity is actually speed. What is the difference between velocity and speed? The difference lies only in the direction. You take the velocity and remove the direction, you get the speed. So that's the meaning. Magnitude of velocity. What do you mean by magnitude of velocity? Is you take the velocity. Velocity has 2 components. One is magnitude and another is direction. You remove the direction, then what is left out? Only magnitude is left out. That magnitude is called the speed. And we will represent the velocity or speed, everything by a small letter v. So it can be velocity also v, speed is also v. So this is the point to be noted when the direction is fixed. Here you have an acceleration is constant. So this point is important. If acceleration is variable, then the answer will be quite different. You cannot expect the same answer when acceleration is a variable. So you also remember that in the given problem the acceleration is a constant, and in addition the initial velocity is 0. How this is going to be useful for you, we will see when you write down the equation. So now the question is, what equation do you want to write? So when you are dealing a problem in one-dimensional motion, we have 3 equations, like v equal to u plus at, s equal to ut plus half at square, or you can have an equation like v square minus u square equal to 2a into distance traveled. These are the possibly 3 equations that are there. Now out of the 3, which is most suitable for a given problem? So the given problem, what is represented, you carefully see this, that our plot has to be between v. So there is a v here, there is a s here. Therefore velocity should be there as a function of s. We need a velocity graph as a function of distance. That is given in the question. Therefore you have to search which is the suitable equation. If you choose this equation, that is equation number 1, I can plot velocity as a function of time, because velocity is here, time is here. If you choose the second equation, then I can plot the distance as a function of time. Distance is this, time is here. You remember, s is not the speed, s is the distance. Come to the third equation. So this is the third equation. I have velocity I have a distance. Therefore, I can plot velocity as a function of distance. So this clearly tells you that since we are interested in getting the velocity as a function of distance, out of the three equations, equation number 1 and 2 are not suitable, right? So you must, you can choose any one of them, but here you can choose this particular equation. Let me choose here like this. So this is the equation that we are interested in. Now, how are you going to solve this problem is, this equation is now rewritten. Take this equation and rewrite that v square equal to, take the u square to the right side, u square plus 2a into distance traveled. And what is the value of the initial velocity? U equal to 0. So this is given here. Since this is given, what will happen? This entire thing gives you that v square should be equal to 2a into s. But 2 is a constant. Acceleration is a constant. Now this is the point which is important. That is why I told you here. So here I have written that there is an acceleration is constant. So that is why it is written. If it is not a constant, then the story is different. Our graph will also be different. So you should be careful about that. So 2 is a constant, a is a constant. So the variables are therefore, v is a variable, s is a variable. So if you take the square root on both the side, we get v equal to square root of 2a. They are all constant multiplied by square root of s. This constant is not important for drawing the graph. Typically, when it is multiplication, if it is an addition, it's required little bit. It is a kind of shifting the graph. You should remember one thing. If there is a plus, plus is called shifting. That means the graph will be shifted. Shifted means moving. You draw a graph in one place and move it to another place. That is called shifting. And you do the shifting when you have a plus sign. If you have a multiplication sign, then it is called a scaling. Scaling means drawing a bigger graph or a smaller graph. Okay, so probably I'll show it here. What do you mean by that? So here I'll come down for the first case, which is a shifting case. What do you mean by that is, if I draw a graph like this graph will go to, I'll move to a different place. For example, I'll move it here. What happened? This graph which is there above the x-axis has come to below x-axis. So this line is below the x-axis, this line is above the x-axis. So essentially I have shifted this below down like this. Then you get this. So this is the effect of shifting. Okay, that's over. Now come to the case of the scaling. Scaling, what you do is, suppose I plot a parabola like this. This will go to a large parabola. So this is a small parabola. This is a large parabola. So this is called scaling. So scaling and shifting are two operators. So you should know that whenever there is a multiplication involved, it's called scaling. Whenever an addition means the subtraction also you have to include. So whenever there is a addition or subtraction, it is shifting. Whenever there is a multiplication or division, it is a scaling. So this point you remember, and then come back to this equation. So what you have is v equal to square root of 2a into, the point is here, there is a multiplication here. Therefore, this portion is going to be scaling. So therefore, it's only a matter of scaling to draw a bigger size or a smaller size. So therefore, you don't have to worry about the quantity square root of 2a. So square root of 2a is responsible for the scaling factor. So no need to worry about that at the time of graphing. So what is left out finally is that we are left out with the velocity is behaving like, I already explained you in the previous lecture that this kind of symbol, you have a symbol like this is called behaving like, or like, you can read like v goes like square root of s. So this is our answer finally. The velocity of the object is going to behave like square root of the distance. That's all. This is the only thing you need to know. Let us see how to plot it. Okay. Now let me write down our conclusion. Velocity is behaving like square root of distance, which means that I have to plot an equation y is something like square root of x. That's what I got to plot. That means if I take a graph like this, put an x-axis here, put a y-axis here, you should know how to put a y equal to square root of x. I already told you how to draw. You first draw a y equal to x graph, which is a straight line. You simply draw a straight line, and then on the straight line you deviate. So if you deviate to the right side, it's a square root of x graph. So the graph will be looking like this. That will be the kind of graph. Okay, if you want to draw separately, without the straight line, then you can probably draw like this. You can draw like this. So if you don't want to draw this portion, straight line portion, you can draw only the square root of x. So this is the graph actually, y equal to square root of x. That means x should be here and y should be here. So this is the kind of appearance for y equal to square root of x. But suppose if you have y equal to x square, then that's a different graph, right? So if I have y equal to x square, then graph will be looking like this. Maybe I will draw like this. Something like this you can draw. So this pink color one is y equal to x square. So these two are quite different. Root x is different and x square is different. So what is our answer? What do you want to, what kind of answer you are expecting for the given problem? So in this given problem, as you can see that we need velocity as a function of distance. When it is moving with a constant acceleration, our graph should be like this. That means v proportional to square root of s, and that is given by this yellow color graph. So our answer is yellow graph. If any graph which is looking like a pink color is wrong, any graph which is looking like a straight line, so you cannot have a straight line. So y equal to x is a straight line. So y equal to x square is this kind of pink color. So this is a straight line. So y equal to root x is our answer. This is our answer. So this is the point that you have to remember. And then now we will go to the question paper and see what are the 4 options given there and check it out what is the correct answer. So let me show you where are the 4 options given. Just remember this. You have to remember the yellow color graph. So where is the yellow color graph? You remember once again, this is the graph. So this is the kind of graph. This is our answer. So our answer is shown here, y equal to square root of x. So this is how the graph will look like, right? And one more point I want to tell you that what about the square root of 2a? The square root of 2a is only a matter of scaling. So when it is scaling, what I mean to say is, let me show one more graph for scaling. Now it depends on how you scale. So you can also scale like this you can draw, or you can also draw like this. This is called scaling. So from here to here you go for scale. So this kind of multiplication would be square root of 2a. That's the meaning of that. It depends on what is square root of 2a. Okay, if square root of 2a is 100, you draw 100 times bigger one. If square root of 2a is 3, then you draw 3 times bigger one. So it doesn't matter whether you draw the graph number 1 or whether you draw graph number 2, doesn't matter. So the behavior is going to be same. That is the effect of square root of 2a. So that is very important. The important point is that this a is a constant. This is very important. If a is not a constant, remember, you won't get this graph. You get it, some different graph you get. So that point you have to be careful. Okay, now we will come back to this thing, and our answer is this. That yellow color one is the answer. And we will go back to the question and then search for what are the 4 options given in the original question paper. Yeah, here it is there. You have the question paper here. So that's the thing. So you have the 4 options are given, and you can clearly find out what's the answer. The correct answer is this, right? The correct answer is this. So this is the correct answer. Let me put a tick here. So our answer is C. I will also tell you why the other answers are wrong here. This is wrong because this is a straight line. Straight line means what? That is, velocity is proportional to s to the power of 1. We don't have s to the power 1. This is correct because velocity is proportional to s to the power of half. S to the power of half means square root of s. So that is why this is correct. And this is also wrong because this is a straight line. Straight line means velocity behaves like s to the power 1. And this is also wrong because this graph you already know that velocity is proportional to s square. So this is a square graph. This is a power 1 graph. This is also a power 1 graph. Whereas only this one has a power half graph. So this is the one having a power half. So therefore this is the correct answer. So correct answer is C is the correct answer. Okay, we will see more questions. So now we will see another question which is also from mechanics. But now it is, I think it is in the AIIMS 2008, I believe. It's something like that. It is once again a question which is based on graphing principles. So as a motion in one dimension. And here if you read the question, the displacement versus time graph is given to you. What is the acceleration of the particle? That's all. That is the question. So you can see by reading this question, you can conclude this. What is given is the displacement as a function of time is given. Find acceleration as a function of time. So that's the question. In fact, here the question, if you read, there is R here. Okay, the acceleration of the particle during the region OP, PQ and QR are given by. That means in the original question paper, you have the 4 options: A, B, C and D. So right now we are not interested in seeing the options. We are always interested in finding the solution, and only then we will look into the answers, because that is the only way you learn it. Learning is different, sitting for the examination is different. If you straight away look into the 4 options and think which one would be correct, then you cannot learn any physics, by the way. So therefore we will never do like that. We always follow a method. The method is like this. First we try to understand the question and try to figure out what will be the answer for that. And at the end we will see what are the 4 possible options given in the entrance examination, and then find out the most suitable answer from the 4. So that's how we will follow. We will now continue now in this particular question. The basic principle is that what is the solution technique is like this. The solution is based on one simple principle, that acceleration, which is a function of time, is given by second time derivative of the position. So this is the basic principle involved in solving this problem. Acceleration is the second time derivative, and similarly you know that velocity will be first time derivative of the position. This position, whatever it is called displacement or position. For example, if you say that this is the position of the particle, then we can calculate the acceleration and velocity by differentiating them with respect to time. So the with respect to time is very important. You see there is a t here. So there is also a t here. So this is very important because, and in your graph also you should be careful to see that there is a time here. Let me draw it. In the given question paper you can see time here along the x-axis. Why this is important is you can also verify that some of the other questions asked in either NEET or whatever AIIMS exam, you can verify that some of the questions will not have time along the x-axis. So in this case this is along the, so t is along the x-axis. Sometimes what will happen is the displacement s will be given on the x-axis. So that should be clear before doing any calculation. If you are not careful to see whether the time is given on x-axis or the position is given on the x-axis, then whatever decision that you are going to make will be wrong. So that is the first point to be noted. And coming back to this, what is our objective? So our objective is that we want to calculate the second derivative. So that means you should know what will happen if you differentiate first time, and whatever you get it after doing the first derivative, you do once again, and that's the second derivative. So 2 times we are going to differentiate. That's the idea. And before doing the problem, the following is the observation from the question paper. Now you see the question paper. There is a region OP. So you can see that this is the point O. So there is a point O here. So this is the point O, and that is a point P. So in the region OP, how the graph is looking like? OP is looking like this kind of a graph. PQ is looking like a horizontal straight line. And what about the other region? The QR region. The QR region looks like this. So that is how it appears. And therefore now you should know that we have already done the previous question, and in our previous lecture we have also explained what are the basic concepts involved in drawing different functions. So if you have followed that, now it will be very simple to find out what this is going to be. So any curve that is going to have this kind of appearance is a square root behavior. That's what is important. That means since the displacement is given on the y-axis, I will write S here. Since the time is given along the x-axis, I will write time here. In fact, everything is coming from question paper. You see here, this is coming from question paper. So the time is given along the x-axis. Similarly, the displacement is given in the y-axis in the question paper. So that is also coming here. So it's there. So based on that only we have to write. So that is coming here. And then if you connect it there, I write S here. So S of t is a quantity that goes like, that is, it behaves like this kind of a structure. So what is this kind of a behavior? Just in previous example also you have seen that the behavior is a square root behavior. So therefore I will write that is a square root of what? Square root of not the y-axis. It's a square root of the x-axis. And what's the x-axis in the given problem? X-axis is time. So it is like this. Y behaves like square root of x. So x-axis should be there here. So that means the region QR. So what is our conclusion is that in the region QR, the curve behaves like square root of t. Now similarly, what is the behavior of the curve in the other two regions? So what about the region PQ? PQ is much more simple. It's a straight line behavior. So I'll write down in the region PQ, your S of t is behaving like mx plus c. And remember that this is a horizontal straight line. Now remember, it is like, you have to write mx plus c, but you have to be, it looks like that, but specifically how do you write? Specifically how do you write? Let us see. This is a horizontal line. This horizontal line, if you extend it here, this particular point is not equal to 0 because there is an origin. So this is 0. So therefore c is not equal to 0. What is the conclusion? The conclusion is that this c is not equal to 0. That is the meaning of that. And then when the straight line is horizontal, what is the slope? That's exactly what we have seen in the last lecture. You have 4 ways of drawing straight line. First way to draw a straight line is like this, up. Second way is to draw it down. Third way is to draw perfectly horizontal. Fourth way of drawing a straight line is perfectly vertical. In the first case, the slope is positive number. In the second case, the slope is negative number. In the third case, the slope is exactly 0. And in the last case, the slope is infinity. These are the only 4 ways you can draw the straight line. And if you see the question paper, you have a perfectly horizontal straight line. So that is clearly visible here. This region PQ is a perfectly horizontal straight line. And therefore, what will be its slope? This m is equal to 0. So you have c is not equal to 0. So here it is horizontal. So that is the meaning. The meaning is this. horizontal straight line will have a slope equal to 0. Therefore, m equal to 0. So if m equal to 0, then what happens? This is 0 times x plus some constant which is not equal to 0 here. And that means it is C. So finally our conclusion is that in the region PQ, our S of t behaves like a constant. This is our conclusion. So this is our second conclusion. First conclusion we have already finished. First conclusion is in the region QR it is over, in the region PQ it's over. Now what is left out? The left out region is this region, the OP region. So now we will do the region OP now. So in the region OP, how the graph is looking like? Just once again see it. In the region OP, graph is looking like this one. Like this it's going. So our graph is looking like this. What is the meaning? The meaning is the y-axis. Y-axis is nothing but the displacement as a function of time, behaves like the x to the power of 2. You already know. So once again I will show you. This is a power half graph. See, when you draw like this, that is an x square graph. When you draw like this, x to the power half graph. When you draw like this, y equal to c. These are the lines. So if you know this, you can get the answer. That's all about it. So now in the region OP, our S of t behaves like x square. Now instead of writing x square, you have to write t square. That is because the x-axis, the horizontal axis in the given question paper is time t. And therefore S of t behaves like t square. So this is your conclusion for the OP. So let me write down that this is the region OP. That's all about it. So once we have the 3 regions which are identified, it is only a matter of differentiation 2 times. So if you differentiate it 2 times, what will happen? So that's the question. So let us differentiate now. Okay, before going to the differentiation, let us come back from the beginning. I'll move a little bit this side. Now the differentiation. I'm not going to the details of introduction to differentiation. Probably that I will do in a next or probably in the next class, for example. For the time being, let me assume that if you have a function y, differentiation of the function will give you dy divided by dx, usually mathematically, which means that there is an assumption that y is a function of x. So this x will come here. In fact, there is a x here. That particular x will come here. This is very important. Now in mechanics, generally in physics in general, the quantity is a displacement, will be a function of time. So what happens is the x becomes a time here. So if it is the case, that will be represented by s. If you differentiate this with respect to, this is differentiate with respect to time. If you differentiate this with respect to time, how do you represent? We represent ds divided by dt. So this t will come here. And if you do this one derivative, this is called the first derivative, and this is what we say velocity. And if you differentiate it once again, so once again what you do? Once again you differentiate with respect to time, second time, that is once again I'm following this arrow. So once again if you differentiate, I will be getting d square s by dt square, and this is what you say the acceleration. So we are going to differentiate the particular quantity 2 times. We are going to differentiate. That's all about it. Now what all you need to know is this much. Suppose if y is x to the power n, suppose if it is given to you, then your first derivative, if you differentiate this with respect to x, you will be getting dy by dx, which is equal to n into x to the power of n minus 1. So this is the standard formula There is nothing, we are not planning to derive it, and there is no need to derive this also for your syllabus. You only need to know that this power has to come here. The power will come here, multiply by, reduce the power by 1. There is a n here. So whatever is the power that you have here, that power you bring it here. After bringing, you reduce the power by 1. And if you do that, that is called one differentiation. And suppose if you want to differentiate it second time, then once again you follow the same rule. So the rule is not going to change. So differentiate this once again with respect to x. Then that we will represent it as d square by d square y divided by dx square. What you have to do is, the constant will not be affected by the process of differentiation. So that is the point you have to remember. Therefore the n will be kept as such. Into differentiation will be done only for variables. Constants, they will be scaling, therefore that will be scaled as such. So therefore n will be written without doing anything. So that factor will come out. What is left out is only x to the power of n minus 1. Therefore as usual, you write down, first you bring the power here. Then x to the power, you reduce the power by 1. So n minus 1, if you subtract 1, I will be getting n minus 2. So this is my second derivative. So you need to know only this much amount of mathematics for solving the problem. Probably you already know the rules for differentiation, but however I am telling you that you need only this formula. X to the power n will give you n into x to the power n minus 1, and any constant, if it is present, it will come out. In fact, you should remember that there is an into 1 here. So there is a 1 here. 1 into x to the power n. And that can be written like this. You can also write the 1 here. So you can say that this is equal to 1 into this quantity. It's very similar. So 1 is coming out here. Now n is coming out here. That's all about it. And we are going to use this formula for doing the differentiation. Now how many things you have to differentiate? We will see that in the question paper. You have to do the differentiation in 3 regions. You see that in the given question paper, you have how many regions are there, you can see. You have the 3 regions. The one region is OP, second region is PQ, third region is QR. In each region you have to differentiate 2 times. So there are 3 regions are there, right? So there are 6 things you have to do. Okay, let us start with the first one. So which is the first one now? OP is the first one that's given here. So you search what is our conclusion. We have already done our conclusions. So you search where is OP. Here it is. So this is our, we have the conclusion here. In the region OP is here. So in the region OP, we have s of t behaves like t to the power 2. This is exactly what you have to differentiate 2 times. So let us do the differentiation now here itself. Okay, take this. You first time differentiate. I will write only d for derivative. So if you differentiate this one time, I will write d for derivative. If you do it differentiation one time, I will be getting ds divided by dt, which is equal to 2 into t to the power of 2 minus 1, which is equal to 2 into t. So your ds by dt equal to 2 times t. This is first derivative. Do once again. So this is once again, if you differentiate means with respect to time. So that is something important. Whenever we say differentiation, automatically you have to understand that whatever quantity is there in the denominator, with respect to that we are differentiating. So therefore d means d is with respect to t. And if you do once again differentiation, we can write d square s by dt square equal to 2 is a constant, write down there. And t is actually t to the power 1. Remember this. T means t to the power 1. Therefore, this 1 should come first. So I will write 1 here into t to the power. You have to reduce the power by 1. That means 1 minus 1. And t to the power 0 is how much? Anything to the power 0 is 1. Therefore, I will be writing 2 into 1 into 1. So, and that is equal to 2. So, our conclusion is that my second derivative d square s by dt square equal to 2. In which region is this? You should remember the region. That our region we are discussing is OP. Therefore, we will say that in the region OP, the region OP, our answer is this. Okay, so this is one answer. We got one answer now. Like this, two more answers we have to get. What are the other two? The second region from the question paper is, the second region is PQ. So come to the PQ region. So where is the PQ region? We have made some conclusion, right, in the PQ region. Where it is? Here it is. This one. This is the PQ region. So what you have to do is, you should remember now, because there is no space here, or probably I will erase it here and let us do it here itself. I will erase this board so that we will get the space to do it right now. Okay. So in the region PQ has only a constant. So I am going to do one differentiation. That is, it is actually the first derivative of the constant C. Nothing else is there. This constant only is coming over here. So this is only one differentiation. That is, this d by dt means first derivative. And you should know that the derivative of a constant is 0. So there are two things are there. Derivative of a constant is 0. The second thing is derivative of x to the power n. Only two formulas you need to know. So that is the answer. 0 is the first derivative. Now this 0, you do the second derivative. If you do differentiation of 0, once again you will get 0. You take 0 and differentiate any number of times, you get 0. Therefore, the answer is this. d square s divided by dt square is equal to 0 in the region PQ. The PQ is here. In the region PQ. So this is our conclusion. In the region PQ, d square s by dt square is 0. And by the way, this d square s by dt square, we always know that this is acceleration. So this is the acceleration. So second answer is also over. And come to the third part. I think that is the last part. And the last part, what is the name of the segment? The name of the segment is QR. So in QR, what is our conclusion? Here it is. We have written the conclusion here. So in the region QR, so here it is. This is the conclusion. The region QR, the behavior is like square root. So this is what you have to remember. Let us try to differentiate here itself if space is there. Okay. Yeah, some space is here. I will try to differentiate here by erasing this board. Okay, that's all. So now we will try to differentiate this here. This quantity. So this quantity you differentiate once. D means differentiation with respect to once. There is a square root. Square root means power is 1 by 2. So that means d means first derivative, d by dt. Square root of t means t to the power of 1 by 2. And that's all. And that's what you are going to differentiate. And that is equal to, so let us first simplify, then we can go back to the, if you do this differentiation, you first put a power here, then put a t to the power, you reduce the power by 1. So that means I will decrease by 1. Original power minus 1. That's all. So and then simplify this. And that is equal to 1 by 2 t to the power of minus 1 by 2. That's all. So this is your first derivative. So this quantity is equal to ds by dt. This is first derivative. We don't want first derivative. We want the second derivative. Therefore, differentiate this once again. If you differentiate it once again, what will happen? 1 by 2 is a constant. Then this power minus 1 by 2 will come here. Then the power will be reduced by 1. So whatever power is there, reduce by another number. If you do that, that is called one more derivative. So that will be equal to d square s by dt square. And I simplify this. That gives me that the acceleration is d square s by dt square, which is equal to, simplify this. So there is a minus 1 by 4 into t to the power of minus 3 by 2. That's all. So this is the acceleration in the case of the third segment. Well, the segment name, if you want to see, you can come back and see in the region QR. QR is there. So this is the segment QR. So in the segment QR, this is the answer. Okay, we have completed the problem. Simply we have to write down the answer. Now, what is the answer that you want to write down? So let us see that. The answer is like this. We have three regions. Let me remember the region and go back. OP, PQ, QR. OP, PQ, QR. There are only three regions. In these regions, what is the acceleration? That is a question. So now we will summary. We will take it and see, immediately write down. Now let us see that in the region QR, the acceleration is negative. There is a negative here, right? The minus 1 by 4 is negative. Therefore, in the region QR, acceleration is negative. So you say that negative means less than 0. That is called negative. Okay, that is in the region QR. What about the other two regions? We will go back to that screen and then find out what did we write there. Yeah, here it is there. You see here. In the region PQ, your acceleration is 0. So 0 means it is neither negative nor positive. So straight away you write 0. So remember this, PQ is 0. So you write down PQ is 0. We'll go back to that place. In the region PQ, the acceleration is 0. It is neither negative nor positive. And what about OP? OP, where it is? OP, you come down. Somewhere we have done. And the region OP, here it is. So there, in the region OP, you got the answer 2. Remember that 2 is greater than 0. So therefore, in the region OP, the acceleration is greater than 0. So write down that. The acceleration is greater than 0. That's all. So this is the answer. So now what you have to do is, you have to open the see the actual question paper where all the 4 options are given, and see whether the options are matching with whatever calculation you have done. So this is the answer. Let us see where is the actual question paper. Yes, so now you can see the question as well as the 4 options are given. You can clearly tell which is the correct answer. So let us see. In the region OP, A is greater than 0. That is greater than 0, equal to 0, and less than 0. So option C is the correct, right? You can verify which is the correct one. So can you see that there is a positive here, 0 here, and then the negative is there. So this is the correct answer. We will see more questions. Okay, in continuation, what we are going to discuss is, we would like to see some questions based on the principles of slope of a curve. So let me write down what we are planning to discuss now. There are some questions that are based on slope of a curve. We are going to see the actual questions of, it could be the question from NEET or AIIMS or similar examination. And there are also some questions that are based on the differentiability of a graph. We can say that, let us say that this is a differentiability and continuity of the graph. So differentiability of a function. This function is only drawn as a graph. Therefore, when we say that differentiation of a graph, it means we are actually talking about the differentiation of the function. Both the questions will be very simple. We will see what are the concept. So first of all, we will take up this particular case A, where we are going to see the slope of the curve, and then we will see an example question. Then we will move on to the concept of the derivative of a function and corresponding function. So we will now discuss the case of the slope of a curve. Now for the case of a straight line, there is no problem. You already know about the slope of the straight line. We have been discussing in the last lecture drawing of a straight lines, how the slope will be looking like. Suppose if you are drawing a straight line like this, this is one straight line. This one straight line will have some positive slope. You already know that you already know because it's based on our previous lecture. We have done previous 2 lectures that are based on the plot of different kinds of functions, including the straight lines. So from that you already know that when the straight line is facing up means it is going like this, it's going in the up direction, then it has a positive slope m greater than 0. The important point is that the slope at this particular point, or the slope at any other point on the straight line is same. That means all points on the straight line will have same slope. This is the important point. You take any point on the straight line and calculate the slope, it will have the same value and the value will be equal to m. That means the slope at this particular point is m, the slope at this particular point is also equal to the same m. It is not a different m, it is the same m. But however, the point to be noted now is that we are not discussing the straight line, we are discussing the curve. You see here that we are going to discuss about the curve. Now for the curve, what's the problem is that the slope is not going to be a constant. It will change from point to point. And the question is that how we are going to calculate. Suppose if you draw a curve, the curve can look like anything. For example, it can look like this, a simple curve, or it can also look like this, or it can look like this. It doesn't matter how it is going to look. Anything which is not a straight line, all the 3 whichever we have drawn, the first curve here, the second curve here, or the third curve here, you take any curve, all of them are not straight lines and they are called curves. And for the curve, you put any point you like, this point or this point or this point, you put any point, and the point to be noted, or the interesting thing is that whenever you change the point, the slope also changes. Therefore the slope at this particular point is m1, the slope at this particular point is m2, this slope will have an m3, that slope will have an m4, and so on. So within the curve, I'm not going, you forget about going across the curve, you take only one curve. This is only one curve. Within one curve, this is a different value. Let us say this is an m3, this is an m3, okay, and if you are coming to this different situation, then it will have a different value. So if this is m3, we can say that this is m4, this is m5, just we are telling different values, that's all about it. So you tell any, or you fix any point on the curve, the slope is going to be different. You are not going to have the same slope. So this is completely opposite to the case of the straight line, where you will have the same slope. Now this concept is different. It is going to have different slope, and therefore automatically we have the question of how to calculate the slope. So that is a question that automatically comes. Now how to calculate the slope of a curve. So how to calculate the slope of a curve? The answer is very simple. We will see the answer quickly. Suppose if you have a curve like this, let me draw it freshly. I'll erase this. So let us say that I have a curve like this. Like this I have a curve. Now we are interested to calculate the slope at this particular point. Let us say I want to calculate the slope at this particular point. What is the procedure? The procedure is a simple, straightforward, and the procedure is same for all the curves. So from one style of curve to another curve, the procedure will not change. It is the same procedure that we are going to follow. The procedure is simple. Let us say what is that you have to do. What all you have to do is you have to draw a tangent. Tangent means is a straight line. Tangent means a straight line. You are supposed to draw a straight line which is touching this particular point. So let us try to draw. Let me draw some straight lines and show which one could be possible. We can draw a straight line like this. So this is a straight line that is touching the point. What point? This is the point that we are interested in. So our point is, this is the point at which we want to calculate or we want to find the slope. That is the point. You put any point you like. Now once you identify the point, you have to draw a straight line. Now you have to draw the straight line. Only thing is that you cannot draw any straight line. You can draw only one straight line in such a way that the straight line will touch the point. That is the first point, condition. Second condition is this particular straight line should not intersect. There is an important point is this. This line, this tangent line, let me write in white. This tangent line, this line is called a tangent. So you should remember that this is called a tangent. So this tangent line should not cross the curve. This is important point. This is the first important point. Second important point is same straight line. This is also same straight line. The tangent line should touch the point at which we want to calculate the slope. These are the 2 points which are very important. So this is the first point. I am putting a bracket from here to here. This is 1 point. And from here to here, this is the second point. So these are the 2 points that you have to remember. If you draw a straight line according to this rule, that is, there are 2 rules are there. First rule is that the tangent line should not cross the curve. The second point is the same tangent line should touch the point at which you are going to calculate the slope. So this is the point at which we are interested to calculate the slope. Okay, and we have drawn this straight line. This is the straight line that we have drawn. Now we will get a doubt. Okay, so that doubt is only I am going to explain now. I will draw it freshly and show you. Let me go here and I'll draw a similar curve for reference. Let me draw a similar curve like that, and then I'll also put a dot like this. Now you can ask the question, what will happen or what is wrong if I draw a straight line like this? This straight line is also passing through the point. So this particular point is there. So this particular point, this straight line is passing through. But what is the problem? The problem is here. So in this region of space, you see in this region, what is happening here is that your line is intersecting or it is crossing the curve. So therefore this particular line is wrong. So let us say that this straight line is not acceptable. So this is wrong. Why it is wrong? Because here it is crossing. Therefore this straight line is wrong. So this is the important point you have to remember. I will try to once again explain. This is the correct curve. The reason is you have only one point where it is touching. That is the first point. You should not touch multiple points. That is the first point. Second thing is it should not crossing. This is a crossover is there. Crossing should not be there. So you have to try to plot. How will you try to plot is, you like when you're drawing the straight line, you can draw like this, like this, like this. You can slowly, you can try which one is best suitable. You can tilt this straight line. So I am now tilting many possible angles. So you can measure the angle, right? So this is the angle. So this is the angle, this is the angle, this is the angle. So that means I am tilting the straight line, and then you find out which is correct. Is this one is correct? Is this straight line is correct? Like this you can draw many straight lines, and then you come to a conclusion that when it is looking like this is correct. That's all about it. Once you finish the drawing of the straight line, your job is over. You can then calculate the slope of the curve. So now let me erase this. Now what is that is completed is now drawing of tangent. Drawing of tangent is over. That is, we have completed it. Next, what you have to do? Next is very simple. Find the slope of the tangent line. Because you already drawn the line, you have to only find the slope of the line now. And that you already know how to find. Okay. So maybe I will explain it once again. Once you have a straight line like this, finding the slope is very simple. So I will draw it from the beginning. Suppose if you have any straight line, I'll erase this. Let me put the y-axis, put the x-axis. So you have x here, you have y here, and you have an origin here. And suppose if you have, this is the straight line that you have drawn. Let us say that this is my tangent. Where do you have the tangent and how does it look like a straight line? That is there here. Okay, so that is there here, this portion. So in this region, you have drawn the tangent. So we are talking about that line now. So this line is what I am showing here. Here, for convenience, I am showing separately. Once you have this particular tangent, you can easily calculate the slope based on numbers here. So here what is required is we need numbers. So let us say that this is 1, 2, 3. Like this you will be having some numbers. Now once you have numbers like this, what all you have to do is you draw a small triangle. Well, this triangle small or big, that doesn't matter much. You can draw a triangle that looks somewhat measurable. You have to measure the length of the triangle. The two sides of the triangle, you have to measure the length. Therefore, if you draw a very small triangle, suppose if you have a straight line and if you put a very small triangle like this, measuring the length is very difficult. Okay. Therefore, you draw the triangle a little bigger so that you can measure the length. Now, you can easily measure the length. What kind of length you have to measure is, you simply measure what is this value and you measure this number. This number, whatever number, this is 2, right? This is 2 and this is 2.1. So what should be that number? That number should be something like 2.05 because this is 2 and this is 2.1. Similarly, what could be this number? This number could be 1.05. And similarly, come to the y-axis and then draw a similar horizontal line and then find out what is that number. And similarly for this also you put it and find what is this number. So this number looks like 0.95. That number looks like this is 2. So this is 2. Whatever it is, it doesn't matter whether you take exactly or roughly. Even you can, it is just before 3. So we can take this number as some 2.6. We can take 2.6. Now, if you identify these 4 numbers, your job is over. So this is an x-axis value. So x-axis value, let me say that this is my x1 because this is an x-axis. See here, x-axis is there. Therefore, this must be x1. This will be x2. These numbers are in y-axis. Therefore, this is my first value. So y1. This is the second value. So y2. So you have x1, x2, you have y1, y2. If you have these numbers x1, x2, y1, y2, you can calculate the slope using the formula that you already know. That means let me write down not y, I will write the slope. So slope is given by m and that is given by the formula y2 minus y1 divided by x2 minus x1. Both are same. It doesn't matter whether you write y2 minus y1 or y1 minus y2. But remember one thing. When there is a 2 here, you see this. If there is a 2 here, here also 2 should be there. Suppose if you write 1 here, here also 1 should be there. That is important. If you are maintaining that, then the equality, this equality is correct. Okay, otherwise you will make a mistake. So generally we remember like y2 minus y1 by x2 minus x1. And this is what we say delta y. Delta y means some difference in y. This is a difference in y divided by, and that's a difference in x. So it's called delta y by delta x. So m equal to that. And you can quickly calculate whatever be the number, it doesn't matter. So in our example here, you can see what are the values. So this is divided by x2 minus x1. I will write down. This is something like 2.05 minus 1.05. And on the y-axis you have 2.6. So here are the numbers. 2.6, 0.95. So I will write 2.6, 0.95. That's all. You take a calculator and then simplify this. That's all. This is the slope. That means calculation of the slope. This is the slope of what? This is the slope of the tangent. What is the meaning of the slope of the tangent? That is the important point now. Now this is the slope of the tangent. This is also known as slope of the curve at the point P. If you are going to represent the point as P, then this is the thing. Now this is the conclusion. We have finished your calculation. Now remember this m is the slope of the tangent. You see this is a tangent line. The slope of the tangent line is also equal to, there's an equal to here, it's also equal to the slope of the curve, but it is valid only at the point P. So this is important. So if you find the slope of the tangent line, tangent means tangent line. The slope of the tangent line, it is also equal to the slope of the curve at the point P. That means validity is only at the point P. So where is the point P? That let us put it, this is the point P. So we say that this point we have drawn is the point P. And this particular in orange line, orange color line that we have drawn is the line that we have drawn separately on a graph here. Here we have drawn so that you can see all the axes. In fact, if you don't, if you are unable to see the axis here, you can draw it. Actually, the axis will be here. So it is like this. When you say graph is there, you have this, all the details are there. So that is your x-axis, that is your y-axis, everything is there. For convenient, we have drawn it separately, and this particular point is the point at which you are going to find this. And the so-called, for finding the slope, you need a triangle, and that is this triangle that you have. And this is the x1, so this is the point x1, and that is the point x2. So all these things is clearly shown separately here. So this is the point for clarity, and this is the procedure. Now the procedure should be clear to you. So there are 3 steps are there. The first step, draw the tangent. The second step, draw the triangle. So you have to draw a triangle like this, or it can be like this. So draw a triangle and then find out the slope, which is y2 minus y1 by x2 minus x1. So if you do these 3 steps, you can calculate the slope at a particular point. So this is validity is only at a point. If 10 points are there on a curve, and if you want to find the slope of the 10 points, you have to repeat the procedure 10 times. So that is important. This calculation is valid only for 1 point. Now, just for information, I will also tell you what will happen if the point changes. Simply you have to repeat it, but I will just show you how the tangent is going to look like. I will show it here itself. So let us say that this is the point. I want to draw the tangent at this point. Then you have to draw the tangent like this. If you want to find the tangent at this point, then you have to draw the tangent like this. If you want to find the slope at this point, then you have to draw the tangent like this. Like this, you have to keep on changing. If you want to find the slope at this point, you have to draw the tangent like this. Like this you have to draw. Okay. And in fact, here you have to be more critical in the sense that this region is already a straight line. So when a part of the curve looks like a straight line, then your tangent will actually match, or it will overlap on top of the curve itself. So that point you have to remember. So if you want that clarity, I will draw it and show you separately. I will show it here. So let me show here another situation. Suppose my curve is like this. This is the curve. This curve, what happens is, a lot of curvature is not there. This curve is different from this curve. So here you have a lot of curvature. This curvature is more turning is there. So here you have more turning. Here you have less turning is there. If you want to find the slope of this particular curve at this point, what happens is, if you draw a straight line, what will happen is that the straight line will lie on top of the curve itself. You can see that from here to here, my yellow line is exactly matching with white curve. This actually happens. There is nothing wrong. This is perfectly correct one. The reason is, you don't have more turning. If a particular curve is not turning, then what's the meaning? The meaning is that it is a straight line. So exactly your straight line is matching at that particular portion. Therefore that will happen. Whereas if you are planning to draw a straight line here, this particular straight line will not touch anywhere else excepting for one point only. So if you draw a tangent like this, it won't match with the white curve. I mean, white curve and yellow curve will be touching only at this particular point, whereas it will touch in the entire region like this. So this is possible when the less curvature is there. So this is like, this is like almost a straight line. No, this is almost a straight line. Therefore this happens, whereas this is far away from straight line. Far away means the curvature is quite high. We say that when you draw horizontal like this, zero curvature. So here you have a lot of curvature is there. If it is slightly turning like this, then we say that it is less curvature. So if you have like this, then a lot of curvature is there. Curvature is changing from positive to negative, etc. So that is the meaning of that. Now depending on this kind of curvatures, and if a curve is like this, you can at this particular point drawing the tangent is quite easy, that it will match only at one particular point. Whereas when the curve itself is not turning, then your tangent line will be coinciding on top of the given curve itself, and that is perfectly correct. There is nothing wrong in that. Only thing is, your straight line should not cross. For example, I should not draw a straight line which is crossing. See, if I draw like this, here is one point touching and here it is one point touching, and in this region there is a crossing is there, crossing of white line and the yellow line. So therefore this kind of line is wrong. This is wrong. Whereas this particular small line that you have drawn is perfectly correct. So this is the principle involved in drawing the straight line. Once you draw this, after that the procedure is quite simple, that you have to follow this diagram and then use the formula y2 minus y1 divided by x2 minus x1 as the tangent. We will see some example problem based on this. Probably in the next screen we will see that. So here we have an actual question that was asked in the year 1994. Probably this is before the NEET examination. It was called AIIMT. So the question can be seen here. The displacement time graph of a particle moving in one dimension is shown, and what is the instantaneous velocity of the particle at the point C, D, E and F. And for once you determine what's the instantaneous velocity, you can determine whether it is positive or negative. So that's also there are two concepts are involved here. The first point to be noted here is that the instantaneous velocity is defined as time derivative of the displacement. This is the first principle. So it is only one derivative you have to do. So this is a physical concept in mechanics. There is a concept in mathematics which says that the slope of a particular curve is equal to its first derivative, typically. So this is also known as, this is one concept in mathematics. So first derivative. So there is a first derivative here. Now what we have to do is we have to combine the concept 1 and 2. First concept is in mechanics and the second concept comes from mathematics. It says that the slope is essentially representing the first derivative of a curve. So this is the principle of mathematics, and now we are going to merge, or we are going to combine the concepts 1 and 2. If you do that, it is clear that you can see the first derivative in two places. Here you have the first derivative and here also you have the first derivative, and therefore essentially your job is, therefore if you combine them, finally you try to find only slope. This means that just to find slope of the curve. That is the meaning of that if you combine the concept 1 and 2. So what all we have to do is we have to find out what is the slope of the curve at the different points. So the given points are C, D, E and F. So let us try to find out the slope of the curve by drawing the tangent. So just now you have seen that whenever you have a curve, the slope at that particular point can be found if you can draw a tangent. So without drawing the tangent you cannot find. So let me draw a tangent. How the tangent is going to look like for the point C. So that could be the line. So we can draw like this, and for the point D we can draw a tangent like this. Of course I am drawing a small line. The line can be large, you can extend like this. It can be, once you draw a line, it doesn't matter, the length of the line doesn't matter, so the line could be very large like this. But however, we are interested to, once you know the shape of the line, you know in which direction it is, whether it is perfectly horizontal or it is facing up or down, only that much information is required. Okay, so therefore there is no need to draw a very lengthy straight line. Of course, by drawing a lengthy straight line doesn't affect anything, but only thing is it should not disturb your drawing for the next point. So coming to the point E, you can draw the tangent like this. It should be straight line, it should not look like curve. So you can use a scale and try. That could be the line. And coming to the point F, we can draw like this. So these are the 4 straight lines. We have completed the 4 straight lines. Now what you have to do is you make a summary and make a quick conclusion. We can get the answer immediately. So at the point C, the straight line is like this. At the point D, the straight line is horizontal, perfectly horizontal. That's important. That straight line, if you draw it correctly, using scale, it should be a perfectly horizontal one. And then at the point E, the straight line is facing down, and at the point F, the straight line is facing up. This is our conclusion. Now what does it mean? The meaning is the slope of this particular straight line, that is for the case of C, the slope is positive. For the case that is at the point number D, it is a zero slope. Horizontal line is a zero slope. For the point E, the slope is negative, and for the point F, the slope should be positive because it is facing up. So facing up means greater than 0, facing down means less than 0, perfectly horizontal means zero slope, and perfectly vertical means infinite slope. So this we have already seen in the last class. So based on that we are now writing. Now the question, if you read, the question is that you try to find out where the slope is negative. So this is the point where it is negative, you have to search, and you can see that this is negative, this is positive, this is not negative, this is positive. Therefore The answer is the point number E. So we will say that point number E is the answer. So where is the point number E now? Because multiple choice question, so you should also search where is point number E. Point number E is the option A. Therefore, our conclusion is that our option A is the answer. So quickly you can finish this question just by 1 minute itself. You can finish. So even without drawing the tangent, if you draw many tangents to many different curves and then get the experience, you can quickly see that without drawing the tangent line itself, we can come to a conclusion which one would be negative. So this is the answer. So we will see more questions later. But only point you have to remember is that almost every question that is asked in the entrance examinations are generally very easy questions. So there are no difficulties are involved. Okay, so we'll stop here.